Hi, your next challenge is called Tribonacci Sequence. Please note that this is in the 6 Caillou category, so if you've been staying up with my current content, we've been doing a lot of 7 Caillou challenges, and so now this represents one tier higher, a step up in difficulty. Don't worry, this first challenge here I think is plenty easy. It would make a good transition if you were thinking about taking that next step to the next level. Anyways, you can probably figure out Tribonacci is a play on the word Fibonacci, as in the sequence. And so let's see how they set that up for us. We'll meet with Fibonacci's bigger brother, aka Tribonacci. As the name may already reveal, it works basically like a Fibonacci, but summing the last 3 instead of the last 2 numbers of the sequence to generate the next. And the worst part of it, regrettably, I won't get to hear non-native Italian speakers trying to pronounce it. Okay. So if we are to start our Tribonacci sequence with 111 as a starting input, they call this the signature, and you can see that in as the first parameter in the method over here. We'll have this sequence: 111, 3, 5, 9, 17, 31. Note the 3 comes from summing the previous 3 elements, which are all 1s. The 5 comes from summing the previous 3 elements, which were 1, 1, and 3, right? 9 comes from the previous 3 elements, 1, 3, and 5. And you can continue that pattern to get all the numbers. But what if we start with 0, 0, 1 as the signature? As starting with 0, 1 instead of 1, 1 basically shifts the common Fibonacci sequence by 1 place. You may be tempted to think that we would get the same sequence shifted by 2 places, but that is not the case, and we would get, and just note that this sequence is significantly different than the one we just talked about. And you can add up the last 3 numbers and calculate those numbers out again. It's good practice. Well, you may have guessed it by now, but to be clear, you need to create a Fibonacci function that, given a signature, returns the first n elements, signature included, of the so-seeded sequence. Signature will always contain 3 numbers. N will always be a non-negative number. If n equals 0, then return an empty array. Sure. And I don't think we need anything else there. So, yeah, hopefully that's clear. The signature then is variable. It'll be passed in to us. They'll basically give us the first few numbers to start with. And since we have 3, we can keep generating values up to whatever n they give us, right? So Fibonacci is a very famous sequence. If you study computer science, you're bound to run into it. So, yeah, good stuff. Go ahead and pause the video and come on back when you're ready. Okay, I'll get into this one. Let's start. I'll just do a little parameter checking because you know me, I'm paranoid. Throw new argument exception. I'll say invalid size passed in. Whatever works for you. And then I'll just go ahead and add using system to access that exception because I didn't define argument exception. And so, yeah, let's go ahead and start by, note they're doing this with doubles, which is a little odd to me. I would have thought they'd use integers, but fine. We don't care, right? They're the boss. So we'll make a new array, and I'll call it my result. I typically do that, and we'll just allocate space here, right? And I'll size it to n, right? This is the size of my double array, and we know the answer is going to be of that size. So that's what I'm doing there. Then, as we'll step through this double array, which is not initialized with anything right now, that's fine, and we'll sort of populate it, right? If it's the first 3 values, we'll use this signature to populate those. Otherwise, we'll sum the last 3 elements. So that could look something like this. We could use a typical for loop. I is less than, you could use result.length or n, they're the same, right? Plus plus I, and we'll define the scope of our for loop. And you can imagine when we're done with our work, it'll simply be a matter of returning the result. But now the real work, let's populate the values. So we had said if I is less than 3, right? If it's 0, 1, or 2, we need to use these signature values. Those are automatically going to be the first 3. So you could say if I is less than 3, result I equals signature I, right? And I suppose to that end, you could also add a safety check here to make sure signature is exactly of size 3, since this is Tribonacci. Try. Go ahead and add that if you'd like as well. Else, right, once we get past those first 3 elements, we should say result I, right, is equal to result I minus 1, the first previous value, plus result I minus 2, the next previous, plus result I minus 3, right? And you can see that I'm taking the sum of the previous 3 elements then, right? And this should always be safe because I is guaranteed to be 3 or greater. So where we could get into trouble is this last one, especially. It marks the furthest deviation from I, but it's only subtracting 3. We know I is at least 3, so in the worst case, you get index 0, which is valid. Because, yeah, as long as n isn't 0. But if n's 0, you're not going to get into this for loop, right? Because it says I less than n. And 0 is not less than 0. So we should be safe there, but we'll find out if not, right? So something like this, I think will do it, and then we'll clean it up a bit. We can condense this into one line in a way that's still pretty readable, but let's just check our work first and then we'll refactor. Good on the test. Hit the attempt. Good. Okay, so yeah, this is perfectly acceptable to submit. We can do a couple things for shorthand that we know about. For one, we can use the conditional operator, right? Or what I've been calling the ternary operator. I pulled that up here, and if you want to see the proper name, they call it conditional. It's with the question mark colon, right? We've talked about that a lot. I've been calling it ternary. But if you were curious about the official term and wanted to read more, you could come to this doc page. So we could say result I equals I is less than 3. If it is, then we use that first assignment, right? The true case comes first, and you use a colon, and then you put your false case, your otherwise case, else case, however you want to look at it. And we'll put that down here. And this is an equivalent statement, right? So I can get rid of this, got it on one line, and we'll even condense it a little bit further, just for fun. Make sure we're still good. And we're still green. Okay, so if you want to get even fancier with it, we don't need the braces when you just have one line for your looping construct. You don't need the curly braces there. And then we could say, well, you know what? This results I minus 1, I minus 2, I minus 3. You could think of that like a subset of the result array, right? So we can use some fancy LINQ statements here. We could say something like this. Result skip, do you remember skip? It's just telling you instead of looking from the front, from index 0, you can start at some other index ahead in this case array, the collection. So I'm skipping that many elements. So imagine I is 5, right? Just we happen to be at 5. So 5 minus 3 is 2. This says result skip 2. It jumps over the first 2 elements and gives you it starts with the third element. And then I can say take. We're always taking 3, right? Grab 3. So if I started with I minus 1, then it's going to give I minus 2, and then I minus 1, which is just what we had printed before, right? And then, do you remember what we did with those 3 values? We summed them, right? So we're kind of leveraging all this LINQ stuff. The skip take paradigm's pretty common, right? You can use that to pull a subset of a collection out, and that's all we're doing here. Start at wherever I say here, and then take however many I say here. Hopefully that's clear. And you know some, we've used that a bunch. So we'll have to bring in the LINQ namespace, right? So we don't get yelled at. And I'll hit attempt, hopefully the same. Good. So that's green. I think I'll leave mine like this, why not? Yeah, so let's go ahead, I'll submit. And go through other people's solutions. I'll do the same on my time. Otherwise, let me know what you came up with. Welcome to the 6 Caillou series. If you aren't comfortable, feel free to stay on the earlier ones. And then it also is helpful for me if you give me some feedback. Like, I think I made enough of the 7 ones, but I don't mind making more if you guys like that and that's helping you a lot. Say, hey, make more 7 Caillou or 8 Caillou, whatever. I don't think I have many 6 Caillou right now, so I'm going to try to beef up that collection too for people who are ready to make the jump. So, yeah, that looks a lot like what we did. I'll go ahead and sign off then. I'll see you in another challenge. As always, thank you very much for watching and your kind comments. Thank you.